now we're going to revisit a topic that you saw in college algebra, but we're going to look at it in more detail. And I'm going to, what I tell students in pre-calculus is why you have to learn it. In college algebra, I don't go into all of that because many students don't care so much. But usually people in pre-calculus might be headed to calculus, and so this is a calculus concept. And so I want to show you how it relates to that. The difference quotient is this. It is f of x plus h minus f of x over h. It's the difference, the subtraction. The quotient part is that it's a division. It's a subtraction, division. That's what our difference quotient is. But what does it mean? It means that it is, oh, that's, okay, thought my battery's running out, but some breaking news, I'll read it later. What it means is, what this is, it's the slope of a line. It's the slope of a secant line. To be specific. So what is a secant line? A secant line is a line that passes through any 2 points on a curve. So for those of you who have had trig or are taking trig or will take trig, secant in this respect does not mean 1 over cosine. It means something different. It means it's a line that passes through any 2 points on a curve. So let's talk about that. Let me pick 2 points. I'm going to pick this point, and then I'm going to pick another point right here. So this is 2 points on a curve, and so now I'm going to connect the points and draw my secant line right here. So if I do that, here is my line. Great, there's my secant line. Now, this difference quotient is the slope of that blue line right there. And so how can we make sense of that? Well, here's the first point on my curve, and I'm going to say that this occurred at x. And so the output, and this is the function f, that's important. So the output of x would be f of x. So the coordinates of this point right here are x, f of x. Okay. Now if I go a little bit further down the curve, down the x-axis, to this point right here, and I really went pretty far down, but that's okay, x plus h. So that means the distance here is h. I went h units further down. This is what I put in here. So what's the output if I put in x plus h? It's going to be f of x plus h. So the coordinates of this point are, the input is x plus h, and the output is f of x plus h. It's whatever I get out of that. So that's the y coordinate. Now, you know that slope is rise over run, or the change in the y's over the change in the x's, and so you learned a while back that m is y2 minus y1 over x2 minus x1. So where x1 and y1 is a point and x2, y2 is another point. And so we have 2 points. Let's look at this as one. Let's call this one x1, y1. And let's call this one x2, y2. So if I take these points and I substitute in that expression, for y2, I put in f of x plus h minus y1, which is f of x, over x2, which is x plus h, minus x1, which is x. I see that in the denominator here, x minus x is 0, and I'm just left with h, and so that is my difference quotient. And that is the slope of a secant line. Now, how does this relate to calculus? In calculus, we're not so much interested in the average slope, but the instantaneous slope of things. And so instantaneous slope, if I did not want to know, like, this sort of averages the slope of this line from here to x plus h. But what if I was interested in knowing what is the slope at the point x? Well, what I would do is I would sneak up on this x, and so I would shorten this distance h. Instead of being this far away, I would have a look at the tangent line maybe this far away. And so I would say, oh, I could get another tangent line. Ooh, pretend like that's a straight line right there. Or what if I wanted to get this far away? Then I could draw another tangent line there. Or this far away, I could draw another tangent line there. And you sneak up on the point x till you get the tangent line. The slope of the line at x is equal to the slope of what is called tangent. This tangent is not the same one as in trig, which means sine over cosine. This tangent means just touching. And so you sneak up on this point. How do you sneak up on that point? With a limit. And so you allow x to go from this distance, h, to be this distance, let h go to 0. And so you let the distance between these 2 points go closer and closer, and you find out what the tangent of that is. So that's calculus, and at the very end of this course, we start talking about limits, and that's why you have to learn it, basically. Right now, our job will be to construct and simplify the difference quotient for these three functions. And you've done this in college algebra, but maybe not with some of these functions. So the first one, f of x, is 3 minus x squared plus 2x. So to construct this, first you have to figure out what f of x plus h is. So let's do that work. What is f of x plus h? I like to just do it. Here's like kind of my scrap pad where I work it all out. So this is 3 minus something squared plus 2 times something. And so instead of x, I put in x plus h. And so then I like to simplify it down before I construct it. So this is 3 minus, this is x squared plus 2xh plus h squared plus 2x plus 2h. So now I'm about ready to put this together. F of x plus h is going to be 3 minus x squared minus 2xh minus h squared plus 2x plus 2h. All of this in the blue is this right here. What is f of x? You don't ever have to go figure out what f of x is. This is always given to you. Whatever function they give you, that will be what it is. So this is minus, and let's put in f of x. F of x is the given function right here. Minus 3 minus x squared plus 2x all over, you just write this down, all over h. We have constructed the difference quotient. What's left to do is to simplify it. So I'm going to distribute this negative. This is going to be minus 3 plus x squared minus 2x. That's what happens there. Now in the numerator, there will be some terms that we can add together. We can collect because they're like terms. So we have 3 minus 3 is going to sum to 0. We have x squared minus x squared is going to sum to 0. We have 2x minus 2x, and that will add to 0. So what we're left with is negative 2xh minus h squared plus 2h all over h. This is the part where you know you're on the right track when everything left has an h in it. You're like, oh, that is what is supposed to happen. So we can factor out an h from the numerator, leaving us with negative 2x minus h plus 2 all over h, and these will cancel. That's what we're really after. We're left with negative 2x minus h plus 2. This is the final answer. This is what I called my simplified difference quotient. So that's that one. Hopefully you've seen something similar to that in a previous course. The next one, I don't know that I showed my college algebra students one like this. You might have already seen it, so that's great if you have. But if you haven't, we're going to look at how to handle one like this. Number 2 on your sheet, construct and simplify the difference quotient for number 2. And they give us y is equal to the square root of x plus 2. Sometimes they call functions f of x, and sometimes they call them y or something else. If you want to, and I want to, change that y to a f of x, go ahead and do it, because that's going to help me see what that is. That's what that is, even though it said y. Okay. Let's figure out what f of x plus h is. Well, that would be the square root of, instead of putting in x, I put in x plus h. And that's really all there was to that. So now let's construct it. F of x plus h looks like this. I'm going to do it in blue. F of x plus h is the square root of x plus h plus 2. And then I have this minus sign, minus f of x minus the square root of x plus 2 all over h. This right here is the constructed difference quotient. Now, the next step is to simplify it. So we have to simplify this. And so to simplify it, this has two radicals in it. And so what we have to use here is we have to multiply it by this guy's conjugate. So what is a conjugate? If you have a plus b, the conjugate of a plus b is a minus b. It's where you change the sign of the second term. So the conjugate of this numerator will be the square root of x plus h plus 2 plus the square root of x plus 2. That is its conjugate. If I multiply the numerator by that, I must also multiply the denominator by that. So I just want to make sure I didn't mess up on a sign. I think that that is okay. All right, so let's multiply. What happens when you multiply conjugates together is something wonderful happens. The middle terms sum to 0, and that's very helpful. Right here, the square root of x plus h plus 2 times the square root of x plus h plus 2. The square root of something times the square root of something is just the something. So when I multiply this times this, what comes out is what's underneath the radical, x plus h plus 2. Now, the square root of x plus h plus 2 times the square root of x plus 2 gets multiplied together. And then we're going to multiply the square root of x plus h plus 2 times the square root of 2, but this has a negative in front. These will sum to 0. And then so all I have left is negative times a positive, which is a negative, times the square root of x plus 2 times the square root of x plus 2 is just x plus 2 all over h times this whole 6, x plus h plus 2 plus, sorry, plus the square root of x plus 2. All right, let's distribute that negative. This is going to be minus x minus 2. Let's collect like terms. X minus x is a 0. 2 minus 2 is a 0. And we're left with the h over h times x plus h plus 2 plus square root of x plus 2. Excuse me. These h's cancel. Now let me find some room to write my final answer. This is your final answer. 1 over the square root of x plus h plus 2 plus the square root of x plus 2. This is your simplified difference quotient for number 2. So right now, just like, why is that? That seems so complicated. It makes more sense when you get into calculus, and having these skills will help you a lot once you get there. Okay, let's do the last one, and then we're done. Yay! Number 3 was to construct and simplify the difference quotient for a rational function. So I think I did give my college algebra students a rational function. So if you had me, you will have seen this before. Hopefully you've seen this before too. But if not, I'm going to go through it. It's no big deal. They say, they give us this function, g of x is equal to 1 over 4x minus 3. Okay. So if you want to momentarily rename your function to f of x so it fits the form, that's fine. Just like I did a second ago for the y. But this is going to be basically g of x plus h minus g of x over h. So it's going to be like this. 1 over 4 times x plus h minus 3 minus 1 over 4x minus 3 all over h. This is the constructed difference quotient. Right here, g of x plus h would simply be 1 over 4, and I replace that x with x plus h, just like that. Okay. I can distribute the 4 times x, 4 times h, so that's going to be 4x plus 4h minus 3. Now, how do we handle this? We've constructed the difference quotient. Now we need to simplify it. If you have a complex fraction, and this is a complex fraction, a nice way to simplify it is to multiply the numerator and the denominator by a lowest common denominator. So what I see here for the denominators is this one times that one. The lowest common denominator is going to be 4x plus 4h minus 3 times 4x minus 3. If I multiply up here, I multiply down here because I'm only allowed to multiply by the number 1. Because that's the identity for multiplication. So what happens here is this will distribute to each term. So 4x plus 4h minus 3 times 4x minus 3 times 1 over 4x plus 4h minus 3. When this gets multiplied here, and if I want to write it like a fraction, I do. When I'm multiplying up against a fraction, I like to write it like a fraction. So in the numerator, you can think of both of these as over 1 if you want to. This times this, what's going to happen is this term will cancel with that term. So all I'm left with is 1 times 4x minus 3 over 1 times 1. So this is all that's left when I do that first multiplication. Here's my minus sign, minus. All right, 1 over 4x minus 3, so let me pretend like that didn't happen. This times this, because this gets distributed here. What's going to happen when the second term gets multiplied is 1 over 4x minus 3, this will cancel with that. So what I'm left with is a minus 4x plus 4h minus 3. What happens in the denominator? Nothing, except for those two terms get multiplied together. So down here we just have this h times 4x plus 4h minus 3 times 4x minus 3. Let's see what we can do up top. Let's distribute that negative 1. So this becomes minus 4x minus 4h plus 3. Let's collect like terms. 4x minus 4x sums to 0. 3 minus 3 sums to 0. Everything we have left in the numerator has an h in it, so that's good news. We have negative 4h over h times 4x plus 4h minus 3 times 4x minus 3. And this little cancellation is what we were really hoping for. And we get negative 4 over 4x plus 4h minus 3, 4x minus 3. This right here is our final answer. It's the simplified difference quotient for that particular function. Let me just make sure that I like my answer. Yes, I like it. Where was this guy's answer? Did I erase him? I erased him. Okay, it looked like it was going to be 1 over this plus this. Yeah, that one was okay too. All right, cool.